Okay, let's dive right into this. Welcome to today's explainer. We are rolling up our sleeves and embarking on a true inspector's journey through a very specific, highly detailed quality report. Today's focus, an in-depth analysis of EDTA MIX Trace Element Fertilizer. We're going to break down its exact component content and the final conclusions of its quality report. But most importantly, and this is the really fun part, we're going to see exactly how the actual test values stack up against the strict manufacturing specifications. So if you're a fan of data transparency and absolute precision, well, you are definitely in the right place. So here's our roadmap for the audit. Section 1 will take an initial look at the EDTA mix. Section 2, the core nutrient analysis. Section 3, the spec versus actual comparison. Section 4 will cover the agricultural advantages. And finally, Section 5 will wrap up with the final quality conclusion.
All right, Section 1. EDTA Mix Initial Look, establishing the baseline.
Now, before we get completely lost in microscopic chemical data, we absolutely have to verify the visual spec, right? In any rigorous quality audit, step 1 is literally just making sure the physical stuff matches the baseline paperwork. What you're seeing here is a pure green powder of EDTA mix. It's bright, it's consistent, and honestly, it perfectly matches the documentation. We really have to ground ourselves in the physical reality of the product before we start trusting the lab results.
Okay, let's talk logistics, because logistics form our entire foundation of trust here. We are looking at a pretty substantial batch, 5,000 kilograms to be exact. Officially, this is batch number 2025-0309, manufactured on March 9th, 2025. It boasts a solid 2-year shelf life, packed efficiently into 1 kilogram bags. Now, getting these baseline specs locked in is absolutely crucial for any procurement officer or ag scientist who's trying to track quality and stability over the long haul.
Moving on to Section 2, Core Nutrient Analysis, the Certificate of Analysis data. Now, what's really interesting about this next piece is the heavy laboratory data. This table right here, it is the absolute heartbeat of the fertilizer. So after passing that visual test for the pure green powder appearance, we hit the heavy hitters, the chelated trace elements. Iron actually tested at 4.2%, zinc came in at 5.1%, and manganese at 2.1%. Then you've got copper holding incredibly steady at 0.5%, molybdenum at 0.2%, and boron at 2.1%. To top it all off, we have a perfectly balanced pH of 7.7. I mean, this is the exact, verified, chemical reality of this specific 5,000 kilo batch. Just to give you guys the complete picture here, it's worth noting this product is also manufactured as a granule, often called EDTA MIX granule. Visually anchoring ourselves with the product in both its powder and granule forms is super helpful before we dig into exactly how these nutrient percentages actually overdeliver on their foundational promises. And that brings us to Section 3, spec versus actual comparison, over-delivering on quality. Okay, let's analyze what these numbers actually mean in the real world. This brilliantly illustrates the in-house minimums versus the actual verified test results. Look at iron. It required 4.0%, but it delivered 4.2%. Zinc needed to be 5.0% and hit 5.1%. Magnesium required 2.0% and landed comfortably at 2.1%. Now, in the world of trace elements, I cannot stress this enough, these tiny fractions of a percent matter deeply. For high-value crops, this strict adherence to and frankly over-delivery of specifications is literally the difference between an average harvest and a premium yield. The product is clearly beating its own rigorous specs. And you know, this over-delivery continues straight into the boron levels, which tested at 2.1% against a strict 2.0% requirement. Plus, look at that pH. It sits perfectly at a highly stable 7.7. That is smack in the middle of a remarkably broad 3.0 to 10.0 acceptable range. So it leans slightly alkaline, sure, but it remains incredibly stable for field application. This kind of verified precision across every single metric? That's exactly what separates your average agricultural inputs from the top-tier, highly dependable ones. Now, in the spirit of completely objective analysis, we have to pause for a quick fact-check based strictly on our source material. Despite inquiries about how this specific EDTA mix formulation performs on agricultural crops in Southeast Asia, our sources explicitly confirm there is zero specific data or case studies provided for that region. Honestly, acknowledging what the data doesn't tell us is just as important as hyping up what it does. It just reinforces our commitment to objective credibility. We literally only report what the data proves. All right, Section 4, Agricultural Advantages, the General Power of Chelates. So while we might lack that specific regional data, we absolutely know how those microscopic percentages translate into tangible macro benefits out in the dirt. Chelated fertilizers are incredibly effective, especially for high economic growth crops. I mean, they play a massive role in promoting overall plant growth, they noticeably improve the outward appearance, and they boost vital chlorophyll levels, which, as we know, ultimately drives up total crop yield. But it's not just about size, it's about internal quality. These chelates enhance vitamin C, sugar, and protein levels. They boost the trace element and soluble solids content, and they even improve long-term storage quality. The trace elements in this exact mix are literally formulated to do the heavy lifting for plant health.
And finally, Section 5, Final Quality Conclusion, the official verdict. So the crucial point is this. We've scrutinized the physical specs. We've seen the really impressive over-delivery of the chemical actuals against the required minimums, and we've explored the real-world agricultural benefits, which brings us to the definitive conclusion pulled directly from the Certificate of Analysis. Quality of this product conforms to requirements of in-house specifications, because every single trace element, from the iron down to the zinc and boron, met or slightly exceeded those strict requirements. This exact batch is officially scientifically validated for agricultural use. You've seen the precise chemical breakdown today. You've seen the strict adherence to quality parameters that ensure maximum impact for those high-value crops. So, I leave you with this. Consider your own operations. Does your current fertilizer actually pass the test with this exact level of documented precision? Keep analyzing the details, keep demanding data transparency, and I'll see you in the next explainer.